Hey guys, welcome back to Introduction to Computer Networks. This is Polly, and we are in week 5, episode 10. And there are more of you popping up. Good morning, Yasin. Actually, hope I pronounced your name correctly. So, hey, let me know, Yasin, if I have been calling you in a odd way, all right? And Changjie, morning, and Xingwen, good morning. We have nothing more to talk about except that, again, gently reminding you that today, after the lecture, we'll do a test run of your camera, of the system you'll be using for the exam next week. Okay. All right, let's go ahead and start. So we are now in the second application, the email. Yesterday you learned about there is a protocol SMTP that connects from the email sender to the email sender's local server. And then in another level of hierarchy, the sender's mail server will be working as a client and then pushing the email to the receiver's mail server. Okay, so there's two-level hierarchy. Today, Polly will start by introducing an example of how this SMTP exchange between a client and the server works. So in this example in particular, you will see the sender, okay, after logging in, can actually send an email in a text mode. So I will show you an example of the exchange between the client and the server of SMTP. And then Polly will demonstrate pretending to be a human email client. Because once again, just like HTTP, the messages, the comments are all in plain ASCII code. So one can actually, a human being can pretend to do that easy. All right. So this video giving you an example and to demonstrate is only 5 minutes and 20 seconds. This is a very simple SMTP exchange. Let me explain the notation. S being the server, C here being the client. Now in SMTP, this is the receiving mail server, and this is the sending mail server. Once the TCP connection is established, the receiving side identifies itself first. 220 hamburger IDU, status code, status phrase. Client here then would in turn tries to identify itself as well. Crepus.friends, that's the identity. And hello here is the command to allow the server to know who the client is. And then server, status code 250, everything is fine. Hello, crepus.friends. And then beginning from here, we start to see control message exchange. Client here needs to specify who the sender is and who the recipient is. So mail sender is Alice and mail recipient is Bob. So all capital here, mail from. All capital here, receive to. Okay, our special commands as well, just like the hello. So whatever comes after the columns are the mailer and the recipient. So server again are just saying, okay, good, I got it, 250. And from here on, this is the actual data exchange. Data, once again, a command. Email starts from here. Do you like ketchup? How about pickles? And it ends with a single line that has only a period. Okay, so the actual email message is only this short, 2 lines. Last is here, just to close. Okay, server will say, message accepted, everything is fine. Client then issue yet another command to quit the session. Server says, all right, goodbye. Very simple. To set up connection, to do the email exchange, and to close the connection. In the email exchange, there's the control message part and then the actual data part. And that is an SMTP message exchange among the client and servers. Let's try now to telnet to an actual mail server at port 25 and see what the server would send back to us. And then we could try to type in some of these comments out and see how the server responds. So let's go to the demo mode. Now let's try telnet to a mail server at port 25. Telnet, which mail server?
actually Googled up Gmail's mail server. The name is this, SMTP, how appropriate, gmail.com, 425. There we go. IP address being 64 something something. And this is the message coming from the server, 220. All right, so SMTP, gmail.com there is identifying itself. And then ESMTP, okay, it's saying more. I'm not quite sure what this is, right? So E must be something and then SMTP. So this might be a special variation of SMTP, maybe the encrypted version, I'm guessing. So let's try typing up some of the comments. For example, hello, and coming from us.edu.tw. How about that? Great, seems to be working. 250. So the server say, ooh, address service. That's really polite. All right. Then let's try the next comment we saw earlier, mail to, and let's have Gmail sending to Polly's email address. How about that? What is this? 530 5.7.0 must issue a start TLS comment first. So yeah, it does look like it's trying to establish an encrypted connection. So TLS, if you recall, is what? Transport layer security support. So I'm guessing this is probably the credential, the public key. So I'm supposed to send back the share secret key with the public key as the key to encrypt. But I don't know how to do that. So yeah, let me try it again then. Playing dumb here. pollys@ntu.edu.tw. Let's see. No, it's not accepting it. So I have to, yeah, so maybe recipient from, Polly's Gmail address. How about that? No, it keeps bugging me saying, okay, let's do start TLS. So that's issue this comment, start TLS, and see, start TLS. Oh, cool, it's accepting. That's nice. Ready to start TLS. All right, so then I suppose I need to send back the, I'm already out. So it seems that the establishment process there also has a time limitation. Otherwise, yes, and hacker might be able to hijack something that you have done in the middle. Interesting. So, hey, I got kicked out. So Gmail is a secure email service. Email messages are encrypted. Nice. Good to know. And so that was a demo of trying to telnet to a mail server, actual mail server. You could also try this yourself, maybe from the workstation. Okay.
Yeah, so that was not a very successful demo, isn't it? And in fact, Polly said send to, but according to the video you saw earlier, it should be send from, okay, and receive to. Yeah. So the comments are also a little bit mistaken, but what you can see from there is that Gmail is sending the email using a secure connection, that is using TLS, remember, the secure TCP. Okay. Now, what I would like to do is now you know a little bit more about SMTP. Let me show you the message format. Okay, so you see that when you send the email, there'll be a bunch of these header lines, that is to inform the mail server or inform the receiving mail server far away about who's sending the email and from which server and etc. Okay, so that's an important part of the email. But there's also the real body of the email, the content that you would like the true receiver of the email to see. Okay, so in the next video, you would now see the actual email, the format, and also the email message format. Okay, so when you start the mail reader, the email you see, there's usually the sender, who's the sender, and who's the receiver. So that's what you see. Okay, but a real email comes with not only that, but a lot of other control information that mostly the mail server or your client machine, the user agent, depend their operations on. Okay, so this video, even better, only 3 minutes 20 seconds, gives you the message format, okay, the entire email message format.
And just a few words about SMTP at the end. Once it sets up a TCP connection, the client there can use the connection to send multiple emails. So it runs just like the persistent connection we see in HTTP. SMTP requires text in ASCII code, very strict. And SMTP uses just a single dot in the last line, okay, to determine whether it's the end of the message. Now, if we compare SMTP to HTTP a bit more, they differ in multiple ways, but they are also similar in another way. So this is the first thing they're different. Yeah, the service sort of direction. HTTP is actually to pull objects down, but SMTP is to push objects out. Now, object here I meant email. They are similar in this way. Comments, responses, all these messages are in ASCII text format. But HTTP and SMTP are also slightly different in this way. Each object is encapsulated in a response message. So HTTP server there sends one object at a time, one object per message. But SMTP can send multiple objects in one message. That message is just having multiple parts. So for emails that comes with an attachment, like a big PDF file after, here is the attachment, if there's anything wrong, contact me. So email, the original text at the beginning, and then additional attachments. They can be sent as a multi-part message. So multiple objects in one message versus HTTP. One object, one message. Mail message format. So there's yet another protocol that defines how the email messages should look like. So this will be the data part of the SMTP protocol message exchange. If you recall in the example earlier, there's the opening phase, some control messages being sent, and then comes the actual data before closing. So the mail messages here we're talking about is the content being sent in the data phase. All right, so these messages are not control messages for SMTP. So they are not SMTP. The mail message format is actually defined in another RFC. It's another protocol. So in that protocol, it defines the mail message format. There are two parts only. The header containing a number of header lines, specifying who the receiver is, who the sender is, and what is the subject of the communication. In the body, very simple, just the content of the communication. So note again that I try to clarify. In SMTP, you see mail from. So this sounds like, following this command, you also tell who the sender is. Receive to, after the comment, after the column, you give the recipient's email address. So it sounds a little bit like the to line in the header line and the from line in the header line, but they are actually completely different things. These go in the data part, while these go earlier, setting up a connection ready for data exchange.
All right, so that's an email. But to give you a better sense when you are using email as an application, let me show you something, okay? So this is Polly's Gmail, and particularly the phishing mail folder. Okay, so Polly actually keep all these phishing type of emails in this folder so that I can investigate and learn what is the latest way of trying to scam your passwords or some personal information. So let me run you through a couple examples so you see a little bit better what are the header lines and what is the email body, okay? So for example, this is, this email declare that it came from Gmail support team, okay? And it's saying that your subscription will close at December 28th, 2025. And this is final warning. Wow. Okay. And if we look into the email, and so I'm using a web browser to read my email. So this is the interface. As you heard earlier in the video, that there are some header lines and then the actual content, right? So header lines are usually these. Okay, so essentially see who the sender is. Okay, and this is claiming to be the Gmail support team. Okay, and this is the receiver, which is, I think, me. Yeah, so my Gmail is here. Okay, and you see that you can expand a little bit to see more headlines. Recall in the video, right? Sent by someone and to this particular user. Okay, and this is from Gmail support team. Date, time, and the actual subject. Okay, and mail by hey. You see the here. This is one of the header line, but this indicates who the mail server is really. Okay, doesn't this look a little bit weird? If this is coming from Gmail support, how come it's coming from a weird sysmactech.com.mx, right? A really interesting machine. And yet in the content, so this is what you see. Okay. And there are more and more mails that look like this. It looks like a web page instead of some text messages. Okay. You know what? It is more a web page because it's nicely graphically formatted. But once again, it's actually claiming that this is Gmail, and my Gmail is expiring. I don't know why, because Gmail is supposedly free. And guys, you know what? You can actually look into more detail about this Gmail, about this mail. So if you go here, if you are also using this is web browser and using the Gmail interface, then you should be able to go to the right and then show the original message entirely. So this will contain all the header lines and all the content. Okay, that's being transmitted from your receiving mail server to you. So this is coming from my mail server to me. So again, you see the header lines, but what I want to show is here. This is the entire email that's being sent between the mail server and you. And your reader would hide many of the content here. Okay. And this is the email. I guess that is probably a picture or some sort of, you see, it's encoded. Okay. It's encoded. You don't get to see what's really inside in ASCII code. So people can send an email like that. But in there, you can probably still click on things and it will probably take you somewhere interesting. Okay. But the header lines will definitely be ASCII because this is how the mail servers interact. Okay. So a few key header lines. Okay. Usually what I go for are these receive here. Okay. And see, guys, if you look into this is actually coming from, interesting, dhgate.com, and from this IP address. Okay, this is also not exactly the server we see here, right? So this is pj something.us. But the server is seemingly odd. Wait, where is it? Yeah, receive. It's receiving from this guy, right? But if you look up just a little bit here, the return address, where is it? Yeah, you see here. Yeah, the authentication, the return address is somewhere else. Okay, this. Okay, and it's a permitted sender. Okay, but down here, you see that it's actually received from this particular server. However, the IP addresses are the same. Okay, so one thing you can be sure that this is actually coming from this machine. So 89.252.158.190. So we can actually look it up and see where that machine is. So I'm actually, pasting the IP address here already. Okay, so what's my IP address? There are actually many other websites allowing you to look up, given the IP address, where the machine is exactly. And this is where the machine is. So the machine is actually in Turkey. Okay, that confirms that I was right being suspicious of the email, because it is very inconsistent at places, right? The message ID says that it's coming from mx.google, seemingly. But if you go into the detail, you don't see, right? But you can see it from here. But this is only when I show the original email, then the email reader here shows the IP address, okay? But this is the true message, okay? The true email message you receive. Again, many headlines, and then the body. So body is always down here. So if you receive something binary like this or somewhat encoded, you want to be very, very careful, okay? So this is one example. Another example, super interesting, which I received just recently, February. So it's a payment receipt. And the reason that I was suspicious of the message is because I did not do any purchasing about that time. Okay, so I take a look, and this is saying, "Good morning, I've sent the payment, best regards," and Ren. Okay, and obviously I don't know the person, and if we click, we see that, hey, it's someone from within NTU. That's even more interesting, right? So someone within NTU is taking my purchasing and sending me a payment receipt. Okay. Let's see what the original message says. What's interesting is that it's coming from within NTU, but it's sending to my Gmail address. But I guess this is because I have forwarding of my NTU email to my Gmail address. So this is explainable. Okay. So Google actually authenticated the sender. So it is coming from this guy, from this server. So let's see whether it's really received from within NTU. Hey, it's received from this machine. And the IP address, where's the IP address? Interesting. Oh, there. Receive. IP address is this. What is this, right? Hey, you can use actually the same technique. So let's copy it over and go to the IP lookup and see where that machine is. And hey, so this service here actually responded with this, because 172 something, that's actually a private address. 172.16, this is private address. Just like 10 something. This is used for local allocations only. Similar to 192.168. This is why when you are configuring in Wi-Fi AP, Wi-Fi AP is, if you recall, right, access network from your home machine to connect to the rest of the internet. Very often you connect to a Wi-Fi AP, and then Wi-Fi IP connect to the rest of the internet. So the real IP addresses that is assigned to your household is the IP address of the Wi-Fi AP. But all the machines at home are using one of these local private IP addresses. So 192.168 is very often the subnet of a home network, okay? And it's probably 192.168.1 something or 2 dot something. It can be all the way to 255. Okay, so the subnet address very often within 192.168. And this example we see is 172. Let's go back and investigate more. That means the mail server that's sending this message is from within NTU. Okay, so I guess this is some students exploiting the IP addresses we've assigned to you guys, maybe from the dorm, maybe from some labs, for experimental purposes. Okay, and so obviously, hey, I might be too early. It might not be a student doing this. Okay, it could be a hacker that compromised a certain lab and therefore doing this. So this is obviously a machine that's local within NTU, and there's a mail server running on the machine. And the mail server, for some reason, managed to send emails to NTU.edu.tw, the NTU's official mail server, and pretending to be someone else. Who's the sender? Here. So this is the sender, and this sender is using this as a sender's email address, sending email from this machine. Super interesting. Super interesting. This is so odd. So this machine is definitely not trying to do authentication of the user, because this is, I'm pretty sure this is a mail server someone sets up locally. So one can actually download a insecure mail server running on a machine and generate spam mails like this. Okay, using all the email addresses they can find within ntu.edu.tw. Okay, so actually look up. This is actually a young professor from the CSIE department. Okay. But I'm pretty sure that the professor's account is not compromised. It's more that there's an insecure server, insecure implementation of the mail server here. Okay, and somehow NTU's mail server trusts machines from within NTU. Okay, interesting, isn't it? So once you know about the email message format, you'll be able to tell better these emails that you receive, whether there are spams, whether there are scams, okay, or normal. Good. So this is just so that you get a idea that, hey, what you're learning watching these videos coming from Poly can be useful. Okay, it's just that you might not really connect to where it will be useful. So email, we use it every day, right? Knowing more how the messages are formatted, okay, what's legit, what's not exactly legit, and how the mail servers connect with each other. So you see earlier in the demo that Gmail is using TLS. So the message going from you to Gmail server, that is secure. Okay. Yeah, let's go on. Last video is very straightforward. It's just to explain how the mail access protocol works. And there are actually 3 protocols that are used, very common. In the later part of the video, you will see Poly demonstrating how the reader's user agent interact with a POP3 mail access protocol. Using POP3 mail access protocol to interact with the receiving mail server.
And then we'll switch gear just a little bit and talk about the last part of email application. So we've talked about the flow of sending an email all the way from Alice to Bob, right? So mail access protocol runs here. Okay, so it's this part of the entire flow. SMTP that we talked about earlier only covers email exchange to the receiver's mail server. In between the receiver's mail server and the actual receiver, it's this protocol that's controlling. So what it does is to allow the receiver to retrieve email from its local server. There are three very popular mail access protocol: POP3, Post Office Protocol, IMAP, Internet Mail Access Protocol, and HTTP. These two, you can see that they are more specifically defined for the purpose, allowing a receiver to retrieve email. The functionality is also similar. First, the receiver needs to authenticate itself, authorize itself, and then begin downloading emails. IMAP, being a slightly newer version, okay, it includes a number of other features, including, for example, we could store the email messages in a more structural way, for example, creating folders and putting certain emails in certain folders. Right. HTTP, however, is special. It's quite fashionable these days. Some of the mail service providers are asking us to use a web browser as the user agent. And then the email server there is essentially also a web server, so that it runs HTTP in the middle and treating each email as a web object. So fetching an email, fetching a web object. Okay, it's the same thing, except that the content is more specifically being emails. And let's take a closer look at how POP3 works. Okay, the exchanges between the client and the server. The notation is very similar to the exchange we saw earlier in SMTP. S being the server, client is C. So there's an authorization phase and then the actual transaction phase. So authorization phase you see here, the client comments very typically being declaring the username and declaring the password. So you see here, in the authorization phase, server says, okay, I'm ready. Client says, I'm user Bob. So the username there is Bob. Password, being hungry. All right. And server responses with either okay or negative error. It's even more simpler. All right. So okay here, okay here, okay here. Maybe with the phrase after that. And in transaction phase, this is where the emails are actually retrieved. So clients sometimes say this, list. So this is to ask the servers to tell back the list of emails there are. So this is more the index of the emails, and a lot of times just containing the file size and maybe the subject line. Right? It's only until the client begin issuing comment like this, RETR. So this is for retrieving messages. So RETR1 indicates that it's retrieving this email. So this is the index of the email, the size of the email, and there could be other information. Then the server sends back the actual content of the first email, and again ends with a period, and only one period in the whole sentence. Right? The client can actually delete an email that has already been read, or in case it's a spam. Right? So DELE, very intuitive, being the delete. Quit, also intuitive, being quitting the session. All right? So retrieve an email, server sends an email, client delete an email, retrieve another email, server sends another email, and client deletes yet another email. Q and then plus OK, server says goodbye. So that's an example of POP3 exchange.
All right, so that was email. So maybe I can go back because you guys seem to be interested in the subject of identifying spams or phishing emails. You see that I noticed that particular email is problematic, right? Because the subject is payment receipt. And you see, I actually receive an email that's very similar. The subject is identical. And in fact, the content is identical except for who's sending it in the end. So obviously, this is something that's automated, okay? But it sounds personal, because purchasing should not, hey, right? So the same receipt is sent twice. So the first time it came from Lisa Chen, and Lisa Chen is actually stefanmatthews97@gmail.com. All right. So just like what Yasin said earlier. Oh, wait. 1 second. So I need to fix this so that you guys can see a really interesting conversation. There you go. Now you guys should be seeing the live chat on on the OBS screen. Okay, you see it on the side, I guess. So Yixin was asking how you can advise, how you guys can advise your parents, right, to avoid scamming emails. And Yasin was suggesting, there are some key features, right? Do this quickly, or something like payment receipt, okay? And I do see, you see here, emails that say we block your account. So this is email says we block your account. Again, we block your account, and many times. And they all come with some graphical icons here, there. So here's I think a cucumber or something like that. Such a subject title also nowadays draw my attention because they try very hard to grab your attention. So you see that the reason that I keep the phishing folder is so that for everything I thought, it sounds odd, okay? So I'm not quite sure whether this is spam or phishing. I put it here, and I'll come back to examine each of them more carefully, and then I might realize that, for example, this is probably a spam. 美国杰出人才. Okay, so this is Chinese. This is actually probably from some immigrant lawyers, okay, immigration service, okay. Guys, if you see any weird emails, keep them, store them. You don't necessarily need to click into the links. So, for example, I actually didn't download this and open it. Once you know it's suspicious, I wouldn't recommend you click on any links or downloading the objects and starting the even it looks like a PDF, even if it's a JPEG image. Okay, so this, right, there are two links here. Click into it, or click here to unsubscribe, or click here to unsubscribe. So any of these links could be fishy. Now, because this one is, this content is actually encrypted, so the hackers are smart. So you can see, but maybe we can see other, for example, here. Yeah, this one obviously very suspicious, right? Because it keeps sending me this. Photo will be deleted, and I've been receiving this for months, and none of my iCloud photos are deleted. So obviously this is a scam. So there are two links, right? They like you to click. One is here and one is here. And let's see if this message is also encrypted. We can scroll down. And hey, this is the end of the header. So you can probably tell that the date and time and content type, right? So this what header lines, the attributes and values, right? So all these internet applications at the high level are ASCII readable, and this is the actual content. Hey guys, this is a web page. And it's nicely HTML is readable, so maybe we can scroll down and identify if we click into that box where it's gonna take us to. And I think it's here, right? Because this is the reference link. This is where the reference objects are. So it looks like if we click into the payment to pay, and so that my iCloud account is not closed, it's gonna take us here. It's actually a URL, and do you want to click into this place? This is a Google Doc, I think, a Google storage, Google Drive. Daily, here we go. .html, it's a web page, but you see these days the URL can be a query, or this is, in this case, a pound. So it's going to a web page to a particular part of the page. And this, again, you don't know what's going on. Okay, and it might trigger a JavaScript, which might not be a good thing. Okay. Yeah, and this is the machine that I do teaching. That's definitely not do this. But if you have a machine that you actually install as a sandbox, then you are free to explore what's gonna happen. All right, so I hope this is interesting and how you can examine further. And so, Yixin, maybe you will come up with something that you can advise your parents, and not only your parents, to the public. Hey, there are these emails recently. We know it's fishy already, and you can actually publish it somewhere so that people can look up. So before they check emails and before they click into something, they can come to your website and get an update, okay, of the phishing emails. All right, so that was email. It appeared like it's simple and normal, nothing special, but hey, things are happening. Okay, so internet is a very, very important target of attack, useful target of attack these days because we go digital. Okay, and hackers somewhere out there, um, if they find your home network's IP address, maybe they can slowly sort of slowly get their way. Okay. I'm not trying to scare you. I'm just saying that what you're learning is very fundamental. If you are interested in knowing how to protect yourself or furthermore protect other people you love very much. Okay. Now let's go on to yet another very important application. And this one is also easily attacked. But let's not talk about how you attack using the DNS service. Let's first learn the DNS. And maybe towards the end, Polly can talk a little bit more how a hacker can attack you exploiting DNS. So, hey, I think I get your attention now. All right, so let's get to learn DNS. Let's know about the nature of DNS. And I can tell you it's essentially a mapping service to map from a host name to its IP address. Okay, so this video, let's see, almost 4 minutes. Okay, the nature is mapping.
Next is chapter 2.4, DNS, which stands for Domain Name System. And before we talk about the purpose of it, let's talk about identifying a person. If I tell you my social security number, my name, and my passport number, which one would you think would be easier to memorize? Well, social security number, 10 digits long. Well, the national ID of Taiwan is also about 10 digits long. You can correct me if I'm wrong. Name, Polly Huang. Passport number, don't even bring this up. Polly does not recall her passport number, as a matter of fact. So very obvious, isn't it? The name is so much easier. But that's just how human brain works. Name, form of ID, much easier. Number, form of IDs, harder, especially when it's a long sequence of numbers. Well, internet, to identify a machine on the internet, shows a similar obstacle. So hosts and routers, many of them have the IP addresses, right? But these IP addresses are even harder to memorize, maybe harder than the passports. And as you're working on the PAs, right, memorizing the IP address of the workstation, super hard. Even though you've already worked on it for a while, if I ask you to type it up, it's probably still challenging. So what we do here on the internet is to give some of the important machines also a name. For example, www.yahoo.com here is the web server of yahoo.com. So you could just type www.yahoo.com and it quickly leads you to Yahoo's website. Similarly, www.google.com, quickly we reach Google. So, hey, how does the web browser know? What is the IP address of the web browser given just www.yahoo.com? Well, that is the functionality of DNS, to identify the mapping between the IP address and the name. And let's talk about DNS more formally. So essentially, it's a database of these mappings. So lots of these IP address mapping entries. Nowadays, it's distributed, meaning there are multiple of these name servers, and there's a hierarchy actually connecting these name servers. Some of them sitting at the higher hierarchy, and some of them sitting lower. What's a bit special about DNS here is if you hear me saying that, hey, a web service will need to query DNS system in order to find the mapping. So hey, web service is already an application level service. HTTP is already the application layer protocol. So it seems that the application layer protocol, HTTP, there needs to work with DNS, which is also an application layer protocol, in order for it to operate correctly. So DNS, in fact, work with multiple of these application layer protocols, not just HTTP, all right? So name servers there would help all these application layer protocols in order to resolve names to the IP addresses. It's a very essential function. Some might argue that it's one of the core internet functions, which might sit underneath the application layer protocols instead. But now we put it in the application layer such that it's only running on the end hosts. If we need to update, improve the DNS servers, we don't need to actually go ahead into the core of the internet, all these routers to change everything. So that makes changes a bit easier. Right? So there's a very special phrase that the internet designer would like to say, which is complexity at the network's edge. What it means that if you come up with something, some function that's very essential and it could go complex, then let's put it at the edges. Let's have it running on the hosts instead of running in the routers at the core of the internet. Okay. And a good side of doing this is so that we could evolve quickly and the performance bottlenecks can be removed quickly. Right.
All right, so from name to IP address mapping. Unfortunately, in the digital world, the machines are identified by numbers, okay? But for human beings, it's easier for us to remember, to memorize like www.google.com. But to memorize the IP address of www.google.com, that will be a headache, okay? I don't even remember my wireline phone number these days, okay? So it's actually harder to remember the numbers than the names. And in the later part of the video, you see that essentially DNS is a database system, okay? And that maintains many of these mappings from the machine name to the IP address. So it's like a lookup service, a yellow page service, okay? And because there are so many machines out there, so many names and so many name to IP address mappings that needs to be looked up. So it's a database, and obviously it's not a single server database. It's actually a distributed database. There are multiple machines, actually lots of machines, okay, trying to keep consistency of this mapping service, okay. And DNS, you will see that it's actually from name to IP address, and IP address is actually a network layer notion. Okay, so if you recall that the internet protocols is actually organizing a layered fashion. So we are now at the application layer. That's really way above. Okay, so if it's a function concerning getting IP address, we should be putting it into the network level, because network level is the level handling how routers communicate. Okay, and IP address is very important for the routers to identify where to forward the packets, right? Because IP address is essentially the destination address on the packets you send. Now, can you connect all the way to the overview of the internet? Okay, so they are all connected. And so DNS being a service trying to find out the IP address of the machine that you want to connect to, it should be in the network layer, but it's actually now in the application layer. Yeah, so internet is such a moving target and a monster. The designer of the internet at the time finds that DNS being a service that's very important, and we might need to change it in the future. Okay, so we actually move that to the edge. Okay, so that we have this complexity at the edge, so that if we need to change it, optimize it, okay, it'll be easier, because it's easier to change the end systems. Okay, takes is for Microsoft or iOS to do a OS update. Okay, but if we have it running in the router, then we need to turn off the router and install the new firmware and set it back up again. And if it's an important router, you can imagine that there's an internet outage here there, and it will probably happen every now and then because such an update might be frequent as long as it's important. I don't know if you about you guys. My web browser, so I'm using Brave these days. The browser actually updates on a weekly basis, sometimes even more frequent, because again, this is a digital world, and you never know that who's really interested in you and trying to find ways in. So they might be interested in you because you are part of an organization that they are truly interested. So yeah, DNS a very important function. And you know what, guys, it's time to take a break. And I see that there's a very interesting discussion ongoing. So Dorothy was saying that, can I kind of just send, pretending to be someone else? And Ivan was saying that, no, it's not that easy. So actually, Ivan has tried, obviously, tried to pretend to be someone else. And the mail server doesn't send the emails for you. And the both of you are right. Ivan, you're writing away that the server that you're trying to do this is actually a secure one. It tries to authenticate the mail server. Okay, and there are more and more mail servers doing so. But Dorothy, you are also right, especially the operating mail servers. But Dorothy, you're also right. As I was discussing the very interesting spam mail where the mail sender is from within NTU. And that spam goes to probably not just me, but also a bunch of other NTU users. So that's actually coming from a server within NTU. And it's not smtp.ntu.edu.tw. It's not the official NTU mail server. It's some other mail server. So it could be some students, after installing Linux, installing a mail server that is not secure, that does not require authentication. Ivan? So you're trying it the wrong way, Ivan. Install a mail server. Okay. All right, so let's see. Yeah. At once. To type it right at once. So, yeah, so Ivan, you can try it again. Okay. Javio also enjoys Brave. Yeah, because it actually filters out a lot of these sort of marketing traffic. Yeah. Nowadays, if you go to a website, the website actually tell that you connect to them, to other people, to other companies, so they can do marketing purposes. And the content you browse from a particular website is probably also propagated to these other companies subscribing to that website. So they kind of pay each other to get more information about you. And it's a little bit freaky these days. Yeah, if you go to a website and you've never been there, but they know already about you. It's not like Amazon, you've been there a couple times and therefore they know about you. You go to a new website and they somehow know about you, right? Yeah, so that's why I switched to Brave. Otherwise, Google is perfectly fine, and it's secure, relatively speaking as well. And it's also very efficient, okay? It's probably because, yeah, okay, so, hey, the reason that we teach in Golan is relatively more efficient and easier to implement, easier to update. And Brave is based on Chromium, essentially just a slightly different version of Chrome. All right, good. So guys, think about these. And after the break, we'll come back to talk about DNS more. After you know more about it, at the end, Polly can talk about how hackers can exploit DNS to attack. All right, good. It's 11:14 already, and let's take a break. We resume at 11:24. Hey, yeah, let's come back to the lecture. So now you know the nature of DNS. Now let's start talking about the specific functions. We know that it's to map name to IP, the host name to the IP address, but that's not the only mapping service it does. There are actually 4 kinds of mapping DNS does. So this next video talks about those 4 functions.
DNS services. There are multiple services actually DNS provides. First is what we've talked about, the most basic one, from the host name to IP address translation. It does 3 other forms of translation. First is the host aliasing. So what happened often on the internet is that some hosts came with host names, but the host names could be slightly longer, indicating where it is or which one of it, number 1, number 2, number 3. Okay, so those can still be slightly harder for users to memorize. So alias name here is often cute and short and very easy to memorize. So this is where the users know the services are, such as www.google.com. All right. So from alias name, DNS allow the web browser to look up what is the canonical name of the server, and from the canonical name of the server, identify the IP address through one of these mappings from host name to IP addresses. So that's how host aliasing works. Second, mail server aliasing, right? So you must have one of these, right? Gmail accounts. If your friend is sending email to your Gmail account, your friend's mail server will need to know who's your mail server. So who's Gmail's mail server? This thing actually looks very general. It's in fact a domain name, not quite a host name. So what happened in DNS is there are also these entries saying for this domain, gmail.com. Okay, all the emails destined to this domain should send to this machine, smtp gmail.com. This we talked about when we were telnetting to an email server to demonstrate the message exchange there. smtp.gmail.com is the actual mail server for gmail.com. So there are also this entry here in DNS service. Okay, and this is called the mail server aliasing service. Last, okay, this one is a bit tricky, but it's growingly popular. It's called the low distribution service. What it does is this: for a host name, there could be multiple IPs that map to it. So IP1, and then the same host name, IP2, IP3, IP4, and so on and so forth. Okay, what happened here is that the DNS might actually rotate, returning different IP addresses each time a web browser or an email server looks up for an entry, okay, for the particular host name's IP address. So that way you kind of rotate using different physical machines every time, and therefore distribute the load of the service. Why not centralize DNS? You heard in the previous slides, there are multiple name servers and there's a certain hierarchy behind it. So why not just one? Well, it doesn't take long. At the beginning of the internet, there's indeed just one DNS server. But it doesn't take long that we realize when the machine is off, the entire DNS service is off. And everyone on the internet, unless you can memorize the IP addresses of all these servers, otherwise, there's not much you can do. Okay, it's off. Second, every application that needs to find mapping IP address given the name, traffic needs to go there. So very high volume. It gets really busy at times. And hey, those users that are around this particular server will have short delay, but they will always be part of the world far away from a particular machine. So delay not ideal. Some could suffer forever. And maintenance, this is a tricky issue, but it is indeed a problem. There are 2 perspectives looking at the maintenance issue. One is that the DNS server software is growingly large. When it grows too large, if you want to make just a tiny little change, you need to turn off the machine, update the code until you can put it back running, right? But all you want to do is just to make a small change. So one small change influences the entire internet. Not good. Second, it's also hard to do the maintenance, right? Because if you want to just do some testing, debugging, you have to take down the entire DNS as well. And when the software grows large, chances are higher that you need to do the testing longer, debugging longer. Not good either.
All right, so hey, we've already said that DNS is a distributed database. Okay, and in just this video, you see that it definitely needs to be distributed to prevent from having a single point of failure. Okay, now exactly how distributed the DNS services, it's in the next video. So finally here, we'll be seeing the architecture of the entire service. Okay, so let me give it to you first now. The whole service has two sides, the server side and the client side. So the clients are the machines that's really close to the end user asking for a mapping. Okay, the server is really the distributed database. Okay, all right. So and in DNS, this distributed database is huge, and we have 3 levels of hierarchy. In SMTP, you see 2 levels of hierarchy. In this one, 3 levels. And in this video coming up, you will see the 3 levels of hierarchy, and the server at each level is called differently, and there's a different number of servers at each level, and each level has its own function. On the client side, we have just one server, and this server is called the local DNS server. It's called local because it's close to the end users it's serving, and it works a little bit more like the proxy server for web browsing. It's close to the end users, and the purpose is really to cache the mappings the users over here have been asking for. Because these DNS mappings, you don't see a particular host changing the IP addresses like every day. No, it's usually a long-term thing. So it's a good idea to cache these mappings that the users nearby have been requested before. Okay, so this local DNS server is actually serving a purpose that is so that the response time, getting the mapping, is faster, and reducing the traffic from the real distributed database to the end user. See? Interesting design, and it's by far the largest in architecture in all the applications we've covered so far. So pay attention to this video, and let me see. Yeah, it's a little bit long, as you can see. It's 5 minutes and 30 seconds.
Therefore, DNS is not a centralized system, but rather a distributed hierarchical system. And this is how the hierarchy looked like. At the top, the root DNS servers. Second level, the .com, .org, .edu DNS servers. The lowest level, or the authoritative server level, the yahoo.com, amazon.com, pbs.org, poly.edu, umass.edu. So what you're seeing here is, hey, .com further breaks up the namespace, and each of these server at the bottom will serve a small range of the names there are on the internet, right? So distributing the load of the name IP lookup. Now, the process of looking up the IP address in a nutshell is this. Client now wants to get the IP address of, for example, www.amazon.com. What it does is first query the top server and try to find the second level server. Query the second level server, next try to find the authoritative name server, the last level. And then from the last level of DNS servers, finding the IP address for a particular host. And let's talk about each of these name servers a bit more. At the top level, the root name servers. It's contacted by the local name server. Now allow me to explain. This local name server is not in the hierarchy. This local name server is actually very close to the client. Typically what happens is that a whole bunch of these end hosts sitting in an ISP will be sharing one. So ISP or institutional network will set up a local name server there for all the users in the domain to send the queries. And then this local name server then will relay the queries to all these servers in the hierarchy, right? So in a way, the local name server here is the client of the name to IP lookup service. So a local name server contacts the root server first, right? The root server then will contact the authoritative name server to find the mapping, get the mapping, and then return mapping to the local name server. Now, the trick part is this. Okay, when I say contact authoritative name server, it's not like directly going from the root to the authoritative name server. There's a certain way of rerouting the query until it reaches the authoritative name server. Authoritative name server is really the one containing the name and IP mapping. Okay, the top level knows the second level. Second level knows the authoritative servers. Only the authoritative name servers knows the exact mapping. And you see here, there are not many root servers. There are 13 logical root name servers, but each root name servers now have multiple physical sites. For example, here in Tokyo, there are 5 sites, 37 sites just for the Swedish root server, etc. So there are quite a few in America, but essentially very few of these root name servers. Next, the second and the third level DNS servers. At the second level, we have a bunch of these TLD servers, top level domain servers. They're responsible each for a different top domain, top level domains. So top level country domains as well, UK, FR, CA, etc. So essentially, this is the last part of the host name there. And each of these TLD server is maintained by some sort of organization of public interest. Some people call them NGO. So for example, Network Solutions maintain the servers for the .com TLD server, and EduCost for the .edu TLD. At the third level, we have these authoritative DNS servers, right? So it maintains the IP host mappings. And it could be maintained by the organization itself or by a service provider if the organization is somewhat small and there are not many entries reading. Right? Local DNS server, this I tried to introduce earlier. It does not belong to the hierarchy, 3 levels. It's very special. Each ISP or institution network will set up one, and all the clients in the institution or in the ISP will configure themselves to send all the queries to this local DNS server, which is also called the default name server. So when a host makes a DNS query, query is always sent to the local DNS server. Now, these DNS servers often carry these caches of recent translation. So whenever we get a host to IP address mapping to the local DNS server, of course, forward the answer back to the client. But in the meantime, the local DNS server also keep a copy of that, okay, for some time. And this is for the benefit that if the client is looking for the same name again, okay, same name IP mapping again, then it's conveniently already cached in the local DNS server, avoiding going all the way to the hierarchy. Right, so nice. But be careful, these entries could sometimes go out of date. So while these entries are cached locally on the local DNS server, well, the entry might have been changed in the authoritative DNS servers. Okay, although very rare, but there's a chance. So these local DNS servers, if you think about it, it works more like a proxy server. Okay, it's not exactly client, it's not exactly server, it's something in the middle, helping relaying the queries, relaying the answers. Okay, so helping forward queries into the hierarchy if there's no hit here at the cache.
All right, so root server, TLD server, authoritative server, and on the client side, you have the local server working like a proxy, right? Like a cache. Now, next is finally, let me show you in a picture, okay, that all these components are there, and the process of handling a query. And there are two ways of handling a query. Okay, so this is what the next video is about, and it's 3 minutes 20 seconds.
So far, we've learned that there's a hierarchy in the DNS servers. There's the top, second, and the third level. And we also know that there's a proxy server there, always working on behalf of the client, sending the DNS queries. So let's try to explain further from the local server here, how the query is forwarded, okay, and eventually receiving a reply. And let's do that through an example. Okay, there's going to be a host trying to reach Gaia.cs, but before messages can go out, CIS poly here needs to find the IP address of Gaia.cs over there. And we're going to illustrate this form of query forwarding. It's called the iterated querying. All right. So what the local DNS server does is to contact the server in the hierarchy, and the server will reply with something like this: name of the server to contact. Okay, someone who might know a little bit better, but I don't have it. So messages looks like this. Root server might say, hey, I don't know about Gaia.cs.umass.edu in particular, but you may ask, hey, the top level domain server for .edu. Okay, someone knows slightly better than I do. Okay, but I do know someone who knows better, right? So that's the general idea. And so the process goes: client here issuing query. Local DNS server now forwards the query first to the root. Root returns the IP address of the .edu TLD server. Therefore, the local DNS server could re-forward the query to .edu TLD DNS. Top DLD DNS does not know the IP just yet, but top level domain DNS does know the IP address of the authoritative DNS server, so that will be sent back. And the local DNS server sends the query the third time, okay, to finally the authoritative DNS server. And finally, the IP address for Gaia.cs comes back to the local DNS server. Local DNS server forward that back to the requesting client and be happy about it. Recursive query is the second form of doing the querying. So local DNS server here will forward only to the root, okay, and not contacting DLD, not contacting the authoritative DNS server. And it will be the root's job to find out what the mapping is. And root doesn't really know the mapping of gaia.cs.umass.edu. So he forwards the query to TLD. TLD forwards to authoritative DNS server, and finally the IP address traversed back. And root DNS server here sends back to the local DNS server. Right? Can you see an issue with this? Yeah, so this way of querying puts burden on name servers that's high up in the hierarchy. There's going to be a lot of query comes to the root, and there's going to be a lot of queries coming from the root to the TLD, although the load on the authoritative DNS server remains the same. Right? So heavy load at the upper level of hierarchies, not good. Keep in mind, there are only some tens of root DNS servers, physical root DNS servers. If everyone is sending the queries always to the root, we could quickly bring down all these root DNS servers. And that's not really a viable solution. Therefore, recursive query is an option that we try to disable at the local DNS server.
All right, so iterative versus recursive. In the iterative model, you see that the local server is the busy one. In the recursive one, you see that the root server, okay, is a lot more busier. Eventually, we'll need to handle the reply all the way to the same route. Okay, so I don't know which way you like better, iterative or recursive. Okay, let me know on the live chat which one you prefer. Okay, and feel free to tell me why. Okay, in the meantime, hey, we go on to quiz 13. All right, so let's go to the whiteboard mode. And this is super open-ended, guys. And you want to hear Polly explaining how you're going to answer, which direction you will go and think. Okay, so the setting is this. Okay, I don't know about you, okay? Being college students, when I was a college student, I had all kinds of thoughts, okay? So this is a kind of thought that I had ever. At some point, I thought, hey, it's time to get real. Okay, so I'm taking all these courses, I'm listening all these lectures and doing all these math and theory and labs. Okay, but what is real? Okay, that's assume that you had the same thought at some point. Okay, you said let's get real. I want to just live the world. Just to know better what the real world is, okay? So you decide it's enough college education, and how about that I start off something, okay? And so the idea here is pet book, okay? It's something very close to Facebook, you can see. It's totally better, okay? It's a social network for pet and animal lovers. Hey, we have plenty of these, right? And they, enjoy having pets around, then they must have a lot of experience they can share. You see? Makes sense. Okay. So pet book here is going to grow better. Okay. So this is Polly's page, and each user use the pet's pic. That's the profile picture instead of yourself. Okay, so this is Polly. By the way, some of you guys asked to see my cat. So this is her picture now. Okay, she's a little bit hard to capture, but here's a nice picture of hers. But she's never really that elegant, by the way. All right. Now you started the pet book. Being your own CTO, and in addition to all these other something O, C something O, CEO, CFO, COO, you operate the company, you actually try to find money to start the company, and you also manage the company. Okay, so this is a one-person company. It's a website anyway. Okay, so one can actually build such a website. So can you structure your server? Hey, what is Facebook? It's actually just a distributed database, much like DNS, isn't it? Well, you can think of the mails also data, right? Then therefore the mail service is also a distributed database. Okay, so how would you structure the servers of Petbook? Okay, so that can actually handle web page queries and send a web page back to the users sending the query. Okay, so again, very similar to what DNS is doing. Now, the question here asked is, how would you model your server? What would the architecture be like? Would it be more like something similar to HTTP's server, or B, something similar to SMTP's server architecture, and C, something similar more to DNS. Okay, so let me elaborate. So these three types, A, B, and C. So this is actually the communication model of HTTP, isn't it? We have a web client, and it sends query to the web server, and then server sends the page back, the content back. So in a way, a World Wide Web is also a gigantic distributed database. All right, so this is HTTP's architecture, very straightforward. What about email? Okay, SMTP. So hey, we now have this local SMTP server, and we have a remote, okay, a receiving mail server. Okay, so you see that, hey, there's one more entity being inserted here. If you recall proxy server for HTTP, hey, that's actually also having an additional server here, right? Except that this server and this server's functionalities are quite different, because email is special being a push service, but web service and DNS queries are also both a pull service. Now, DNS. Ooh, wow. Okay, so we not only have a DNS local DNS server, but we have like 3 levels of hierarchy here at the server side. All right, so if you look at this, okay, this way. So from HTTP to SMTP, you see that at the client side, the architecture expands to actually having no hierarchy to having some sort of hierarchy, one level of hierarchy. And look at this. This is the server side also can expand from having no hierarchy to have 3 levels of hierarchy, right? Actually, if we consider this being 1 level, then this should be 2. But what I meant is actually more that we have 2 levels of machines, okay, interacting. So here we have 3 levels of machine. So this expansion is on the client side, and you grow from just 1 level of machines to 2 levels of machines. And then on the server side, one can also grow like this. Okay, so that's what I meant. There are 3 different types of architecture. One is used by HTTP, one used by the SMTP, and the last one used by DNS. Now think without the protocols implementing different architectures. So you see essentially 3 types of architectures, right? One can build your distributed database from. Would you do it the A way, similar to HTTP? Would you build it in B way, similar to SMTP? Or would you build it in C way, similar to DNS? Okay, so I'm not asking you to combine these three, HTTP, SMTP, or DNS, to try to build your own system, because you are your own system. You can define your own message exchange. What I'm asking is whether you would like to use this type of architecture, or this type of architecture, or this type. Okay, and hey, feel free to pick one that you like, or using a hybrid of these. Okay, developing something your own, type D, for example. What's more important is that you give it a thought and justify your choice. Okay, and guys, as you can see, this one is actually a little bit challenging, isn't it? So it's super open-ended. So be given a good amount of time. So how about let's allocate 8 minutes time? Yeah, that's probably enough for you to come up with some sort of nutshell solution. Okay, good. So guys, 8 minutes, and let's go to the Discord space. It should be there in week 5 quiz 13 channel. So go there and think more. 8 minutes, it's now 11:50, so we'll come back 11:58 to check on the solutions. All right, so let's begin. Okay, Dorothy. Okay, quick thinker. Okay, so I guess Dorothy is very attentive to the lectures today. So Dorothy says 3. Okay, something like DNS, right? We want to balance the server load so that there's low delay. So hierarchical server side, such as DNS, would do better, right? And that's keep a cache. Okay, so that is assuming that the pet book pages don't change all that often. So I guess that's fine, because typically the page stays static. The authors don't come back to change the same picture or same post all that frequently. Katie, also quick. I would model my service after a HTTP, similar, a simple client-server model, where the client send request and the server respond with the web objects. So you can actually implement the page, implement the service as a website. Yes, very good. Fits Petbook really well, since users are constantly requesting things like pet profile. All right. Yeah, so I guess the differences between what Dorothy or Team 3 and Team 2 are thinking is that Dorothy probably anticipate that the pet book is going to be popular, right? And Katie might be thinking that, hey, I don't know, let's start as a simple page having a server, and that's it. Let's see, Junhan, Team 12. All right. With the anticipation of explosive number of users in the future, Yeah, using this seems better. Good. I think the thinking is similar to Dorothy. Okay, so one is aggressive, and team two, Katie's approach is more conservative. But I have to say, as a startup, right? Katie's thinking is actually more realistic. Cautious. Maybe it's probably better put this way. Cautious. I would say that in a startup team, you will always need to have someone who are aggressive, and you will also need to have someone who are cautious. Oh, Junhan receives support. Okay, so you like your post. Right. All right, so many of you are still typing. Yeah, we do have time, so take your time. So Jim Han was using a really nice emoji. Where did it come from? It's like a Superman kind of emoji. I don't see that in the standard emojis. Yeah, super villain. Interesting. Junhan, how did you get this? Did you purchase that from Discord? Very interesting. Yeah, I see Team 10, Ember, says DNS. Data across a global network. Oop. And the caching property will remember the address. All right. Okay, a similar approach to Team 3, and Junhan is Team 12. Very good. Let's see, Sparrow. Oh, you beg to differ. Very good, Sparrow. Love it. Okay, for the bravery. As the service just started, there might not be that much user, so there's no need to implement DNS. Interesting. However, it's important for the user to get a nice user experience. Yeah, I kind of correct here. At the start of the business, even when it's a bit crowded. Okay. Sparrow is actually taking a standing between Katie, Team 2, versus Team 3. Yeah, somewhere in the middle. So it's kind of scalable either way, isn't it? Okay. Hey, to start a company, I think, making sure that your company is flexible is definitely a good thing. All right, I see more teams have concluded. I would use DNS as we expect Petbook to grow big. Okay. Hierarchical structure to prevent a single server overloaded. Yeah, I think this is definitely the case. Okay. The juice box for Team 18. And Yixin. I like to use an HTTP-like hierarchy. My idea of the social network structure is that people's story are posted on a public space so that everyone can access each other's main page. More centralized system directly without extra need for equipment requirements. Yeah, so it's definitely simple. Polly is also someone who loves a simple solution because you have a good idea of how the system is like. So in case there are issues, it's easier to debug as well. Interesting. Simplicity. Simplicity is a good thing. So have you discovered that as long as you find a reason to justify, people would think that you are, thinker. You are flexible. You are agreeable. You agree to other people, and people potentially can agree with you. So guys, you guys will eventually be an engineer. Well, hey, presumably will eventually be an engineer. Engineers communicate too. So try to be agreeable. So Polly has been exercising that, and see if you can exercise that on a daily basis. Then you'll be also a good communicator. I think in this AI era, human skills are more important because many of the programming skills can be replaced by AI engines. So Ray here says HTTP. Could be up to date, making proxy server saving. So, different information like it should be better to use HTTP to allow server. Okay. So I think Ray is talking about using HTTP to do the query and response. Okay. So query. Okay. So Ray was not much talking about the architecture though. So team 23, Ray, think about it. Okay. Yu Zheng, I think that's it. Oh, okay. First hybrid solution, HTTP plus DNS. Oh, I see what you are saying. I think this is probably what Ray was going at. Except that Ray actually said that he wants to use HTTP, and he meant what you meant here. Okay, so you want to use DNS architecture for the server structure. But in terms of sending a query for the web page and getting the reply of containing the web page, containing the pepper page, you use HTTP, and it's probably HTML page there you are implementing. Yeah, because all the contents on the internet pretty much go through HTTP. Occasionally, probably other. So there are a few other that allows other content. For example, video content. But HTTP for static, an object. Okay, static object. HTTP is a common choice. Yes. Okay, so I think team 16 probably filled team 23's answer in. Thank you. You guys probably didn't know that you are helping each other. 26 here. I would like to choose option D. Okay. A hybrid architecture mixed with HTTP and DNS. Okay. Interesting. Yeah, 26 and 16. Okay. Come up with the same idea simultaneously. Aha. Coincidence. Okay. Fist bump between team 16 and 26, I guess. So obviously you guys would appreciate each other's thinking. I think HTTP might not be the best here. It's a simple client server, meaning that the users would all be requesting from the same server. Oh, okay. Yeah, so Yassine was actually giving reasons, and the reason is going into the detail, right? When you operate Petbook with just one single server. So recall a couple of videos before, we said that, hey, DNS must be a distributed database, so that it won't be just one server being a single point of failure. Okay, it'll be easier also to update the server in case we want to debug what's going on, right? And while you are debugging, there should be another copy of the server still running. Okay, otherwise, hey, your clients will definitely complain. Petbook is a banger idea. It will surely blow up. Oh, right. Access. So the users will all demand, right, fast response. Yeah, because SMTP is more like a chained, okay, model of transferring content. Therefore, an hierarchical architecture, so maybe a little bit more like iterative, okay, requests would do better, right? So that kind of balance the delay and load. Okay. So far, Yasin's design is the most complete, right, guys? Yeah, that deserves a tropical drink. Team 13 is growing bigger than Facebook. Oh yeah, be massive. So DNS being also large scale, it seems it makes sense to you, right, Zheng Yan? Petbook should be build something similar to DNS so that it can handle high load. Very good. So the argument makes sense. 右程, I choose C. Okay, so it's DNS-like. Query loading, hierarchical structure, and having a cache. Very concise. Okay, 右程 deserves a big beetle. Okay, let's see. Jordan? I guess, guys, those who think longer always kind of give a more sort of well thought and balanced solution. And once you think more, you will be able to describe the architectures that you're hoping for in a concise way, which is perfectly fine. Okay. Yeah, to be more precise. Okay, so Team 7 elaborated. The same kind of pads. Oh, interesting. Oh, okay. So, hey, Jordan was saying that, right? So we have top level, second level, third level. So maybe we could, at the second level, we could separate the pet pages that are, dog owner pet pages versus cat owners pet pages, right? And it seems that the users asking for dog pages are more likely, right, to ask other dogs' pet pages. Interesting. So you are also talking about the design of your hierarchy, and that's one step further. Thinking, yeah, what's in the second level? This is very good. So hey, how about bubble tea here? All right, Jordan, enjoy. 听起 HTTP plus DNS. All right, so you came up with the same thing as what we've seen earlier, right? Team 16 or 26, or both of them, isn't it? Yavio or Felix, I would model my server after HTTP. Okay. I have to say, right, HTTP without, 3 levels of a hierarchy, the response will be the fastest in case there's not much load, isn't it? So in terms of the best response time, yeah, HTTP architecture, the simple client server, architecture is the best, simply the best. Okay. Oh, interesting. But hey, Team 9 thought about what if the server is loaded? So maybe I can have multiple HTTP servers, but they are all flat, not, 3 levels of hierarchy. Interesting. And you can have some sort of load balancer maybe before that, and you have multiple servers and it's just 2 level. So hey guys, very interesting, isn't it? So what let me go back a little bit. What Felix is saying is this: server, multiple server, another one, and another one. So there could be 3 of these. But maybe I can have a server here being the load balancer, and then distribute load to these servers. So this will be 2 levels of hierarchy. Okay. And so, but this is not probably the best way to draw. It's probably that there's a root server doing the load balancing, and then, multiple server here and here. So it's somewhat similar to this hierarchical, but not that many levels of hierarchy, isn't it? And it goes flats like this. And this, did you mention that you want a cache? Local cache? Okay, no. So the main point of design from Team 9 is a 2-level hierarchy, something in between, isn't it? Interesting. Guys, are you getting this? Okay, a trophy. Okay, nice. Yeah, I know the times is up. Let's see how many more. Oh, we just have 3 more teams, and Ethan is also typing. Let's go over these, and then I'll see you next week. Okay, so Team 25, you will do 2. Oh, okay, it's an if condition. As a startup at the very beginning, use B, right? So the second model, having a cache for the local client, and 3, having 3 levels of hierarchy when it grows. And in 3, proxy server will allow storage locally so that the response would be faster. Okay. Gains more user than SMTP, then can handle model 2, and then scale to model 3. All right. So it's a dynamic design. Okay, so this is Sherwin, team 25, and Yuqi, team 22, DNS. Okay, it's distributed throughout. Okay. Yeah, so this is definitely to handle the growing user number. Can classify by different breeds, color, okay. Can call respective. Yeah, so maybe the lowest level hierarchy, right? So this dog, cats, at the second level, and the lowest, right? There are many different breeds of dogs. Okay. So you can have huskies, you can have border terriers, right, at the lowest hierarchy. Yeah. Okay, a hedgehog there for team 22, and Annabelle. DNS, because if Pepper grows, yeah, so such an hierarchy might benefit better. Okay, sustaining the service. All right, so guys, that's all. Oh, wait. Okay, I almost missed Team A's, Ethan. I will use HTTP. Can easily send the relevant information back to the client. Allow certain information photo to be shared. Okay. Yeah, so it seems to Team 7. Yeah, so how about just go with the simplest architecture, HTTP. All right, so why not? All right, good. So that's all for today. And I'll see you tomorrow because we are not quite yet done with all we want to have in the exam. So next week, we'll continue to cover the rest of DNS. We have not yet talked about the message format, have we? No, right? For every protocol we design, we talk about the architecture. We did talk about the architecture of DNS. But what about the messages being transmitted, right? So there's another half of DNS we are yet to cover. So that's going to be in next week. And we'll also start talk about this other example called BitTorrent. Okay, it's a way the ancestor of P2P based design. Okay, so Bitcoin, which is very popular now, and a large P2P network, okay, came from a similar idea of BitTorrent. So we'll talk about P2P, the benefits of doing it in P2P, and also the drawback of using the P2P architecture. Okay, so that's next Tuesday, and Wednesday will be the exam. And so starting from now, I say goodbye, but let's wait for some 5 minutes. So I will start the Google Meet session for you to do the test run at 12:20. So join at 12:20. So I need to close the stream first, otherwise people will see you guys' face. All right, good. So with that said, bye. But you guys will stay for the test run definitely. Okay. In case you are very, very sure that your desktop or laptop is gonna work fine, of course, you can skip the test run. Okay, maybe you can also come a little bit earlier next Wednesday to do the test run before. It's just that you might get a bit anxious in case it doesn't work. Okay, bye. All right, thank you for the participation. Yeah, quiz 13. Very good to see you guys' solution. 12. Quiz 12. Okay. Why the receiver end use mail access protocol, right? Yeah, it's just hard to maintain that connection for push service to work to a receiving end that's coming and going and changing, because users are like this. We are not always on the internet, unlike servers. So I think the bottom line is probably more that the way we use email, isn't it? Okay, bye. So I have not yet started the session yet, because that way you guys won't accidentally join, because the stream is still public. Okay. It's just a check. It's just a check to make sure that you can, so I can see you. So it's a short test. So all you need to do is just to join and let me see if it's okay, and then you may leave the Google Meet session. All right. Good timing. I'm ending the stream now.